Ever pondered about the birth of our very own star, the sun, or what makes it continuously radiate that warm, life-giving light? Well, today we dive into the fascinating cosmic journey of the sun's formation and its processes. Our story starts about 4.5 billion years ago in the heart of a swirling cloud of gas and dust known as a nebula. With the influence of gravity, the nebula started to collapse in on itself. As it did, it began to spin, causing the material to flatten into a spinning disk with a hot, dense central region. This, dear listener, marked the birth of our sun. Now you might wonder, how does the sun manage to shine so brightly for so long? The answer lies in the heart of our star, where nuclear fusion occurs. This process involves the combination of small atomic particles to form larger ones. In the sun's core, hydrogen atoms come together to form helium, and in this process, a tremendous amount of energy is released, which we perceive as heat and light. But the sun,
the celestial body that lights up our days, is essentially a massive, ceaseless nuclear reactor. Indeed, the sun, a star located at the center of our solar system, is a powerhouse of nuclear reactions. It derives its energy from a process known as nuclear fusion. This process involves the fusion of hydrogen atoms to form helium, in a dance of subatomic particles that releases an immense amount of energy. To understand nuclear fusion, one must first understand its counterpart, nuclear fission. In nuclear fission, a heavy atomic nucleus splits into two or more smaller nuclei, along with some byproducts. This process, while powerful, is not as efficient or as clean as nuclear fusion. Nuclear fusion, on the other hand, is like a perfect marriage of particles. Two light nuclei combine to form a heavier nucleus. This process releases a vast amount of energy, and it's what powers the sun and all other stars in the universe. But this isn't a process that happens easily. It requires extremely high temperatures and pressure, conditions that exist at the core of the sun.
The sun doesn't just radiate light and heat. Occasionally it throws a tantrum in the form of coronal mass ejections, or CMEs. These are large expulsions of plasma and magnetic field from the sun's corona. When these eruptions reach Earth, they can cause spectacular displays of auroras or, in more severe cases, disrupt communication systems.
Now imagine the sun as a colossal, turbulent sea of hot, glowing gas. Amidst this turmoil, sometimes a large amount of this gas gets ejected into space. This phenomenon is known as a coronal mass ejection. These are massive bursts of gas and magnetic fields that are released from the sun's corona, its outermost layer. Coronal mass ejections are associated with solar flares, the sun's most violent eruptions. When these ejections reach Earth, they can cause geomagnetic storms that can disrupt power grids and telecommunications. But don't worry, our planet's magnetic field generally shields us from these solar outbursts.
Now, some might mix up fusion with fission, but they are quite different. Nuclear fission is the process of breaking down large atomic particles into smaller ones. This process releases a large amount of energy as well, and is commonly used in nuclear power plants on Earth. To recap, our sun was born from a collapsing nebula about 4.5 billion years ago. It shines due to the process of nuclear fusion in its core, where hydrogen atoms merge to form helium, releasing vast amounts of energy. On occasion, the sun also releases coronal mass ejections, which are large expulsions of plasma that can cause spectacular auroras on Earth. And remember, while both fusion and fission release a lot of energy, they function oppositely. Fusion combines small atoms into larger ones, while fission breaks large atoms into smaller ones. So the next time you see the sun shining brightly in the sky, take a moment to appreciate the fascinating cosmic processes that make it possible. It's not just a bright spot in the sky, it's a testament to the incredible forces at work in the universe.
In a nutshell, the sun is a ceaseless nuclear reactor, powered by the process of nuclear fusion, where light nuclei merge to form heavier ones, releasing an incredible amount of energy. This energy fuels all life forms on Earth. At the same time, the sun is also a source of celestial weather, with coronal mass ejections being one of its most dramatic phenomena. These massive bursts of gas and magnetic fields, while potentially disruptive, are also a testament to the sun's dynamic, ever-changing nature. So, the next time you bask in the warmth of the sun, remember, you're experiencing the effects of an ongoing nuclear fusion process, millions of kilometers away. And that, the light that brightens our world, the heat that warms us, is the result of an incredibly powerful, yet beautifully intricate dance of subatomic particles.